produce 1 unit of food, it requires 1 worker. To produce 1 unit of clothing, it requires 2 workers. The total amount of workers available in the economy is fixed and is equal to 100. Denote by F the units of food and by C the units of clothing produced. Number 1. Tabulate the different combinations of food and cloth that can be produced given the resource constraint. Okay. Alright, so this is first what we need to do. So we know we need 1 worker to produce 1 unit of food, and we need 2 workers to produce 1 unit of clothes, two workers to produce, yes, 1 unit of clothing needs 2 workers, yes. So we're going to put it like this, and we've got 100 workers. Okay, so this is the equation we can make. This equation is going to help us get our combinations. All right, so we need 1 worker to produce 1 unit of food, and we need 2 workers to produce 1 unit of clothes, and we have only total of 100 workers. Okay, so we can make a table like this. So here we're going to say combination food in units, clothes in units, workers for food, workers, clothes, total workers. Okay. Yes, so let me illustrate how this will work. All right, so we can say, okay, we'll start with combination A. All right, combination A, we're going to say we produce 0 units of food. Okay, so if we say producing 0 units of food, if we substitute it in the equation, it becomes 1 times 0 plus 2C equals 100 workers. We want to find out how many units are going to, of clothes will be made if we don't make any units of food. So 1 times 0, that is 0. So you have 2C equals 100. Remember, all the units of food I'll be putting into this equation to get the units of clothes. Okay, so
Sir, just a minute. We got screen.
Sure, I'm sharing it. How about the others? Are you able to see my screen?
We have seen it now.
So you mean now then sharing it the whole time?
No,
Okay.
on my side I was seeing it.
Okay. It rained today, so network probably. But don't worry, I'm also recording. Okay, so for those who couldn't see my screen, this is the equation we formed. Okay, to make 1 unit of food, you need 1 worker. To make 1 unit of clothes, you need 2 workers. The total number of workers you have is 100 workers. Okay, so now we're going to be putting in, we'll just be choosing the number of units of food, then we'll find out how many how many units of clothes we can produce basically. Okay, so what I'm saying is this: if you produce 0 units of food, how many clothes can we produce? So that's what I put in the equation here. C 2C equals 100. To get the value of C, we divide 100 by 2. 50 units of clothes. Okay, so if we don't produce any food, okay, we just tell all our 100 workers to work on clothes, they will be able to produce 50 units of clothes. Okay, so now these 3 columns are just to make sure that we keep our total number of workers at 100. Okay, so if we're producing 0 units of food, how many workers are we going to have? So remember, said for 1 unit of food you need 1 worker. Now if it's 0 units of food, you just say 1 times 0, 0 workers. Okay, I've just used this part of the equation here. 1 worker for 1 unit of food. So if you make 0 units of food, 0 workers. For the clothes, if we're producing 50 units of clothes, how many workers are we going to have? So we just, this 2C part of the equation here, 2C. So C in this case is 50 units, so we're going to say 2 times 50, that is 100. So 0 workers plus 100 workers, we get a total number of 100 workers. Any questions before I move further? Okay, we go to combination B. Okay, as I said, you can pick. If you want, you can say, okay, next I'll try 5 units, next I'll try 10. Okay, so I'll just jump straight to 20 units. Okay, if we produce 20 units of food, how many units of clothes can we produce? So we come back to this equation here. We produce 20 units of food. So where there's F, substitute it with 20. 1 times 20 plus 2C colleagues, just hold on. Okay. Equals 100. So 1 times 20, that is 20. So you're going to say 20 plus 2C equals 100. Okay, we want to find out how many units of clothes can we produce. So we take this 20 over the equal sign, and we have 2C equals 100 minus 20. It gives us 80. So to find the value of C, we're going to say 80 divided by 2. That gives you 40 units. Okay. So if we produce 20 units of food, okay, we can be able to produce 40 units of clothes. Okay. Now remember, for the food it needs 1 worker. So this 20, you multiply it by this 1 here. In this expression I've written 1F here. Okay, 1 worker for 20 units. So you're going to say 1 times 20. You get 20 workers. So you're going to need 20 workers to produce these 20 units of food. Okay. Then for the clothes, okay, 40 units of clothes. and each unit requires 2 workers. So in total you're going to say 2 times 40, you have 80 workers. So you need 80 workers for the clothes. So total number of workers 20 plus 80, again 100 workers. Okay, let's say combination C. Say, okay, now I want to produce 40 units of food. So if we produce 40 units of food, okay, how many units of clothes can we produce? So again, you come back with this equation here. 40 units of clothes, so where there's F, substitute it with 40. 1 times 40, that is 40. You cross over this 40 over the equal sign. 100 minus 40. Yes?
I can't see the screen is blank.
Yeah. Try to log in and log out. Just try to log in and log out. Yes. So we cross this 40 over the equal sign. 100 minus 40, that is 60. So to get our value of C, you're going to say 60 divided by 2, you get 30 units of clothes.
The screen is not showing, huh?
Yeah. Okay, colleagues, what we can do is this. If it's not showing, hey, some people have been kicked out again. Okay, I'll continue recording. Okay, I'll continue recording. I think it's network issues.
It's showing now.
Okay, maybe before I proceed, do you have any questions so far? Right. So if we produce 40 units of food, we are going to be able to make 30 units of clothes. So if 1 unit of food needs 1 worker, and we are producing 40 units, so we're going to need 40 workers. Okay? We're going to need 40 workers. Okay? Then for clothes, if 1 unit needs 2 workers, 30 units is going to need 60 workers. 2 times 30. When you add 40 plus 60, again you get 100 workers. You have to just make sure you've got the total number of workers should be constant. Okay. Combination D, let's say, okay, now I want to bump up production of clothes. We'll say, okay, I want to produce now 60 clothes. We come back to this equation here. We want to produce 60 units of food. So you come back to the equation we made, where there's F 60 plus 2C equals 100. Okay, so 2C equals 100 minus 60. 2C equals 40. C equals, to get the value of C, we divide both sides by 2. 40 divided by 2, that is 20 units of clothes. So if we produce 60 units of food, we're going to be able to produce 20 units of clothes. So if for food 1 unit is needed for 1 worker is needed for 1 unit, For 60 units, you're going to just multiply 1 times 60. You're going to get 60. For clothes, 2 workers for 1 unit. So for 20 units, you're going to need 40 workers. For 20, no, here I'd put 30 here. Yeah, 2 times 20, that gives us 40. Total number of workers, 60 plus 40, 100 workers. If we say now, okay, point E wants to produce 80 units of food. Now, you can notice the trend here. Food is increasing by 20s. Clothes are decreasing by 10s. So if you want to produce 80 units, you will know that, okay, I need to produce 10 clothes. Okay? Because we've seen the trend already. I'm increasing the units by 20, and the clothes are decreasing by 10. So you can see 50, 40, 30, 20, 10. So you know, if we produce 80 units, we'll only be able to produce 10 clothes. Okay? There's no need to even go to the equation now. So if 1 worker is needed for 1 unit of food, and we have 80 units of food, we just say 1 times 1 worker for each unit. 1 times 80, we're going to need 80 workers. Okay, 80 workers. Okay. Clothes. One unit of clothes requires 2 workers. So for 10 units are going to require 20 workers. 2 times 10. Okay. So 80 plus 20, 100 workers again. Okay. And finally we got combination F. Okay, we say, okay, now we produce 100 units of clothes. We know we cannot produce now any 100 units of food. We now know we cannot produce any clothes. Okay, so the number of workers needed for the food, 1 times 100 equals 100 units. For the clothes, 2 times 0 equals 0. Okay, 0 plus 100, 100 workers. Yes. Any questions so far? Okay, we go to the next part of the question. Use the information in your table above to construct the production possibility frontier curve, with C on the vertical axis, or close on the vertical axis, and F on the horizontal axis. Okay, so we will now make our production possibility frontier curve. This Ppf curve just shows us the combination of goods and services that we can produce when we utilize resources efficiently. That's what the Ppf curve shows us. So we have clothes, and we have food. So for clothes we're going to have here 50, 40, 30, 20 and 10, then 0. For food we're going to have 20, 40, 60, 80, 100. Now this ppf curve is going to have a straight line. Why? Because we can see we've got the drop is constant for the number of clothes. Okay, if it was changing erratically, then the shape wouldn't have been a straight line. But let me even just illustrate. So at first, if we produce 0 units of food, we're producing 50 clothes. So this is combination A. Remember, combination A, we're producing 0 units of food and 50 clothes. Combination B, we're producing 40 units of clothes and 20 units of food. This is combination B. Combination C, we are producing 30 units of clothes and 40 units of food. For combination D, 20 units of clothes, 60 units of food. Combination, that was combination D. Combination E, 10 units of clothes and 80 units of food. That was a combination E. Then the final combination, which is F, 0 units of clothes and 100 units of food. Did I? Yeah, combination F, yes. So as you can see, this is a straight line. That because my graph is not to scale, but this is a straight line. Let me put here 100. So this is your production possibility frontier curve. Okay.